So sorry I couldn't be there today, guys. But luckily, you guys have the foundation to solving quadratics using quadratic formula. I know that typically I would go over homework questions next, but just save your questions for when I come back on Friday. And I promise to have those answered. Okay, so we're just going to go ahead and jump straight into notes. And you should already know that the expectation is that after the notes that you will do a cool down. I will have it set to unlock in the last, I'd say like about 10 to 12 minutes of class. Okay, so that way I know you're not jumping straight to the cool down and then attempting the notes. All right, so here we go. So for today, our essential question is, how do we use quadratic formula with word problems? So we've looked at these word problems multiple times. We're talking about throwing an object, talking about when does it reach a certain height, or when does it hit the ground, or at what time is it at a certain height, etc. So let's first review kind of like what we talked about yesterday. Our warm-up is just to solve the following quadratic using quadratic formula. So my hint here would be make sure that it is equal to 0 first. So hopefully you pause the video. If not, pause it now before I start. The first thing you're going to do is you're going to want to add 10 over. Because before I can solve any quadratic, I always need to have it equal to 0. Now I can identify my A, B, and C values. So A, B, and C. Now we're going to throw it into quadratic formula. So the opposite of B makes it positive 2 plus or minus the square root of b squared minus 4ac all over 2 times a. All right, and I know I say this a lot, but just take your baby steps here. So I like to simplify first what we call that radicand, and we can also do the denominator as well. And so now I get 2 plus or minus the square root. All right, so kind of just relying on my mental math here. So 2 squared I know is 4, and then 4 times 3 is 12, and 12 times 2 is 24. So 4 minus 24 all over 6. And now this is kind of in my way here, so hopefully you've got this written down. Next, I'm going to keep simplifying my radicand, and I notice that I'm going to get negative 20 in there. So we cannot square root a negative. So this is going to be no solution. No solution. Alrighty, so let's dive into our first example. It says, here's an example of someone solving quadratic equation that has no solution. So go ahead and take a moment to study their work, and at what point did you realize that the equation had no solution? So for me personally, I noticed that it wasn't going to have a solution at the second step. Okay, so right here, once I saw that they subtracted, or they subtracted 9, but once the quadratic equaled a negative, so when the quadratic, I'm going to put quad, equaled a negative, because we know at that point we would have to square root, right? So that just reinforces the idea here that, hey, I cannot square root a negative, and therefore there's no solution, just like our warm-up. And same with number 2, explain how you know that the following equation has no solutions. Well, I would eventually, so I'd say I would begin with subtracting 49, right, to both sides. And so we would get x squared is equal to negative 49, and we cannot square root a negative again. So I'd say cannot square root a negative. There's a lot of writing on this one. All right, let's look at the next example. So now we're going to actually see it applied to our word problems, which is that, corresponding to our essential question for the day. It says answer each question, but we're not going to graph, we're not going to factor. It says the following equation represents the height and feet of a potato, t seconds after it has been launched. So a friendly reminder, t is time, h of t is height. Write an equation that could be solved. So that's the key phrase here, right? We're just writing an equation that can be solved to find when the potato hits the ground. Oh, Next sentence goes on to say, then solve it. So if it's on the ground, think about, what do I know? I don't know time because that's what I'm trying to find, but I know that the height, if it's on the ground, right, is going to be 0. Therefore, I'm going to take that given equation that represents the height of the potato, and we are going to set that equal to 0. And now it's just a matter of using quadratic formula to solve. So take a moment, pause the video, and try solving it on your own. All right, I'm just going to change my color here. Okay, so I've got A, B, and C. I like to label those. Let's go ahead and throw it into our formula here. So we've got opposite of B plus or minus the square root of B squared minus 4A C. So we've got bigger numbers. Don't be intimidated by that. All over 2 times A. All right, now I'm a bit restricted here because I'm writing on my iPad, so I'm going to try and zoom in just so we can get more space. So the next thing I'm going to do is I'm going to personally simplify my radicand and my denominator. So now I have negative 80 plus or minus the square root, and this comes out to be 10,496, all over negative 32. Now, as you know, we are going to go into 2 different directions, right? So this is where it gets a little messy. I don't have a whole lot of room here. So here I'm going to branch off. I'm going to go in one area or one direction where I'm going to add whatever the square root of that number is, and in the other direction I'm going to subtract. Now, the square root of that number is 102.45, and I'm going to divide that by negative 32. So 102.45 all over negative 32. Now, if I were to add those like I do at the top here, my outcome is going to give me negative 0.7. In the bottom, or when I subtract, my outcome is going to give me 5.7. So because we are using this for a real-life problem and application, we have to understand that these values represent time, and time cannot be negative. So my solution here is going to be 5.7. So let's look at another example. In question B, it says, write an equation that could be solved to find when the potato is 40 feet off the ground. Okay, I'm gonna zoom in just right off the bat to give myself more room here. So if it's going to be 40 feet off the ground, rather than setting my equation equal to 0, because it's not on the ground, it is now going to be set equal to 40. And then I'm going to start by subtracting 40 over. And now I get negative 16t squared plus 80t plus, 24 is equal to 0. And we can go ahead and label A, B, and C if necessary. A, B, and C. And now we can plug everything into our equation. So the opposite of B, so negative 80 plus or minus the square root of 80 squared minus 4 times A times C, which is 24 now, all over 2 times A. So like always, I like to simplify my radicand and my denominator at once. So I have negative 80 plus or minus the square root of, let's see, that's going to be 7,936 all over negative 32. Okay, so, well, look at this. So much more room. Way to go, Mrs. Lewis. Okay, so now I'm going to go in 2 different directions, right? One where I'm going to add, so negative 80 plus whatever that square root is divided by negative 32, and then negative 80 minus whatever that square root is all over negative 32. Okay, so let's go ahead and square root that answer, and we get 89.08. So now that we know we're probably only going to get one answer, although sometimes if it's not necessarily on the ground, like it could be at 40 feet off the ground in 2 places. However, I know for a fact it's only happening once because if I look at the problem, it's starting at 64 feet off the ground. So I know it's only going to reach 40 feet on its way down. So kind of looking at the top one where I'm adding, I know that that's going to give me a negative answer. And I'm not even going to bother throwing that into my calculator because I don't want a negative answer. So I'm going to go ahead and do the subtraction one, and that's going to come out to be 5.28. All right, backside, another example. So the following equation now models the height in meters of a pumpkin after it has been launched from a catapult. So I want you guys to pause here and try this one on your own now that you've seen a pretty lengthy example. But starting with the first question, is the pumpkin still in the air 8 seconds later? Explain how you know. Okay, so think about what they're giving you there, what information, and then B is at what value of t does the pumpkin hit the ground? Really hope you guys pause the video at that point. So to answer question 2A, is the pumpkin still in the air 8 seconds later? Okay, so think about what information is that. They're giving me a time, right? So time is t. So I'm going to go ahead and I'm going to plug that into answer. So 2 plus 20, whoops, forgot the 2. 23.7 times 2 minus 4.92 squared, right? If I evaluate that, that comes out to be negative 122. So then the answer to that is no. The height is negative. It's already hit the ground. So then it kind of helps me with 2B, right? I know it's going to hit the ground before 8 seconds. So to solve that, I'm going to take my equation and I'm going to set it technically equal to 0. Now be careful here because they have mixed up your equation, right? Usually we have the negative 4.9 t squared first. So when I plug everything in, it's going to be opposite of b plus or minus square root b squared minus 4 times my a. Whoops. Oh, that fooled me. Not 2. A is negative 4.9, although I end up multiplying it by 2 because that's c all over 2 times a. Okay, so let's see, how much room do I got? All right, so we're gonna go this way. So when I simplify that, and I'm just gonna skip the square root here, but I'll tell you what the decimal is. You get negative 23.7 plus or minus. The decimal comes out to be 24.51, all over negative 9.8. Remember, we only wanna take the positive solution, which in this case is 4.92 seconds. And I would have gotten that by doing the subtraction route, just FYI. All right, last example. This is very much an earned honors credit type question. Now, it says earlier in the lesson we talked about a picture frame. We didn't. We actually skipped that question. So this is our first time seeing this. So basically what we have is a 7x4 picture, and it is being framed. So in each direction, they're adding an x in this direction, an x to the width, right? Because we're framing it. So on top of the 4-inch width, right? Because so our goal here is to explain in 2A. So here's my example, or my equation. This represents the length of the picture, and this is the width. The 2x in both cases represents the added length, technically in each direction, of the frame. Okay, now, oops, I forgot to include what it equals. It equals 38, right? So this is going to be my area altogether. So if I have to solve that equation without graphing, well, it's factored and it's not equal to 0, so I can't use the factored out answer here. I'm going to have to put this back into standard form, and then I'm also going to have to get that equal to 0. So what I would have to do is we're going to multiply here. So I get 28 plus 14x, distribute the 2x, and I get 8x plus 4x squared. All of it is still equal to 38. We'll worry about that in a second. So I'd probably go ahead and combine my like terms here, and I think I might rewrite it, make 4x squared go next, just because we like standard form with the highest exponent written first. Next up would be plus 22x plus 28 is equal to 38. Now, of course, from here, I have to get it set equal to 0. Oh, man, Mrs. Lewis, I'm really writing big. I'm going to run out of space here. But when I subtract 38 over, I get negative 10. So now I can identify A, B, and C, and we could use quadratic formula to solve. Man, I really wish I didn't write so big. Okay, so here's what I'm going to do. Hopefully you wrote smaller. I'm going to go ahead and erase what I have above here, just so I can do my work. Okay, so let's see. Let's rewrite that. So 4x squared plus 22x minus 10 was my equation, right? So this is A, B, and C. So when using quadratic formula, I'm going to say opposite of B plus or minus the square root of B squared minus 4A is 4, C is negative 10, all over 2 times A. So this comes out to be, my radicand is 644, and my denominator is 8. So then when I square root that, of course, we get a decimal. So I get negative 22 plus 25.38 all over 8, or negative 22 minus 25.38 all over 8. Now, this one's going to give me a negative. Whoops, I wanted to do that in a different color. Okay, so I'm not going to want that. That's going to be a negative answer. Can't have negative length, right? This comes out to be 0.42, and that is our value for x. So at this time, hopefully you've got enough time to do your cool down. If not, that is going to be your homework tonight, and it will close Friday. Alrighty, hope you guys had a great day, and I will see you tomorrow.